Hello dear students, here we will discuss about the equation of a plane progressive harmonic waves. Before we will discuss about plane progressive harmonic waves, let us come to know what is simple harmonic motions. A particle possesses simple harmonic motions, or a motion is said to be simple harmonic motions if the particle possesses periodic or oscillatory motions and the restoring force is directly proportional to the displacement of the particles from its equilibrium position, and the restoring force is always directed towards the equilibrium positions. We consider a simple pendulum, that is a ball hang with a string. If we push the ball to a position A, the ball will swing between A and C through the equilibrium position B with angular velocity omega. Here the motion of the ball can be represented as simple harmonic motions because it shows the periodic or oscillatory motions, and the restoring force is proportional to the displacement, and the restoring force is also directing to the equilibrium position B. Here B represents the equilibrium position. This is the equilibrium position. So the motions of the ball can be represented by a waveform as shown in the figure 2 in this way. Here lambda represents the wavelength, t represents the time period of the ball, and y represents the displacement at any instant. And the wave is traveling along the x direction, and here a represents the amplitude of the motions. Here a represents the distance between B to A or B to C. That is, this is the maximum displacement from its equilibrium position. That means from the OX axis to this peak point, OS axis to this peak point. Here interestingly, A is always constant in terms of a simple harmonic motions. So the displacement at any instant can be represented by this equation, y is equal a sine omega t. This equation is known as the wave equations for simple harmonic motions. Now come to the plane progressive harmonic waves. So what is plane progressive harmonic waves? A wave is a plane progressive harmonic waves if the particle of the medium performs simple harmonic motions about their mean position and the wave continuously advances in the forward direction. So we consider a set of particles and the simple harmonic disturbance originating from the O. So the wave will start from the origin O. Here O point represents the origin of the system. So the wave will travel in the positive x direction. Suppose it is moving along positive x directions, along the positive x directions with velocity v. And we consider a point P at a distance x. So the displacement at any instant for the wave can be represented by these equations as we have already gained from the simple harmonic motions or simple harmonic wave equations. If a disturbance occurred at O and it will reach the point P after time x by v second, since t is equal x by v. X is the distance and v is the velocity of the wave, not the velocity of the particle. This is the velocity of the wave. So the displacement occurred at point P will be the equal to the displacement occurred at O earlier to the time x by v second. So we can replace t with t minus x by v. So the displacement at point P can be represented by this equation. Here y is equal a sine omega t. This represents displacement at any instant, and here this equation represents displacement at point P. Since we know the value of omega, we can rewrite this equation into this format, and since Vt is equal lambda, that means velocity of the wave and time period is equal lambda, and using these equations we can rewrite these equations into these three different wave equations. Here we can put twice pi by lambda is equal k, and k is known as the phase constant, and using this term we can rewrite this equation into this format. Here this equation is known as the plane progressive harmonic waves along with the other equation. All these equations are known as equation of a plane progressive harmonic waves. So here we considered that the wave is traveling along positive x directions. If the wave travel along negative x direction, that means in this direction, then we will, in this equation, we will replace this negative sign with positive sign, and this equation will represent the equation of a plane progressive waves moving along the negative x directions. Let us clarify this concept with an example. Here we have to find out the equation of a plane progressive waves. And here few conditions are given. Depending upon these conditions, this is the initial condition, we can draw the wave equation. So in this way. So here O is the origin and wave is along x direction. Wave is along x direction. A is the amplitude, which is given by 0.6 centimeter. Lambda is the wavelength given by 36 centimeter. T is the time period. These data are given in the questions. So here at t is equal 0, x is equal 0, that means initially the particles is at point O, and at that moment y is equal 0. So here the displacement is also 0. Since we know the wave equations is this one, so we will convert this equation into another format, this one. Here we know the value of amplitude A, wavelength lambda, and time period t. That's why we will put this value and we will get our required wave equations for the progressive waves. Here if we put different value of x, then we will get different value of y. That means for different position of the particles here and here, that means for these two positions, x2 and x1, we will get different value of displacement, that means y1 and y2. Here we will put different value of x, we will get different value of y. In this way we can derive the equation of a plane progressive waves.